Hi guys, welcome to Scholars. Myself Biswajit Sir, your faculty for geography. So in the last class, we talked about geomagnetism, and moving on from that topic, today we are going to talk about the rock system of the Earth. Okay, so in today's class, the first thing that we are going to talk about is your elements on the Earth's crust, right? So after understanding your elements on the Earth crust, we'll go on to understand the minerals on the Earth crust. Then we understand the rocks on the Earth's crust, and finally we'll talk about the different types of rocks that are found on the Earth's crust, right? So the first thing that we'll talk about is your elements on the Earth's crust. So firstly, what are elements? So elements are considered to be pure substances which are made up of atoms, and cannot be broken down. By chemical process. So this is the definition of elements. Alright. So if you look at the periodic table, how many elements do we have? In total, we have 118 elements, right? Understood this? Fine. So let us look at the first point. What does the first point states? It states that about 98% of the total crust is made up of 8 elements. So 98% of the Earth's crust is made up of how many elements? 8 elements. And what are these 8 elements? Oxygen, silicon, aluminium, iron, calcium, sodium, potassium and magnesium. Remember in the last class when we were talking about the interiors of the Earth, what was the most abundant material which was found on the crust? It was your oxygen, right? And your oxygen was followed by silicon and then aluminium and then iron, right? So this is about the Earth crust. Again, remember, this is about the crust, right? So if we talk about the abundance of material altogether of the Earth and not just the crust, which is the highest element that we get, remember what do we get? We get iron. And then iron was followed by what? It was followed by oxygen, right? Then it was followed by silicon, then magnesium. Understood? So this is for the overall Earth, and this graphical representation that you see here is for the Earth's crust. Fine. So the elements in the Earth's crust are rarely found exclusive, but are usually combined with other elements to make various substances called as minerals. So what are minerals? Minerals are nothing but they are combinations of what? These are combinations of different elements. Understood the difference between minerals and elements? So minerals are made up of elements, and elements are pure substances having atoms and cannot be broken down by chemical processes. Fine. Alright. So now let us talk about minerals on the Earth's crust. Okay. So what is a mineral? A mineral is a naturally occurring organic as well as inorganic substance having an atomic structure and definite chemical composition and physical properties, right? So a mineral can be both organic as well as inorganic, right? So it will have an atomic structure and a definite chemical composition and physical properties. Fine. So a mineral is composed of two or more elements. We have already said, right? A mineral is composed of 2 or more elements, but sometimes single element minerals like sulfur, copper, silver, gold, graphite also are found. Meaning what? Minerals can occur as combination of 2 or more elements, or a single element can also constitute a mineral. And what are the examples of this kind of minerals? Sulfur, copper, silver, gold, graphite. Understood? So the basic source of all the minerals is the hot magma in the interiors of the Earth. So what is the basic source of all minerals or elements? It is the magma, right? So this is the Earth's surface. So magma is flowing from the downward direction towards the Earth's crust. So this magma, when it cools down here, what will we get on the Earth's surface? We will get minerals. Understood? These elements combine to form minerals. Alright. So when magma cools, what happens? So when magma cools, crystals of the minerals appear and a systematic series of minerals are formed in sequence to solidify so as to form rocks. Alright. So first what did we define? We defined elements. Then what did we define? From elements we get minerals. Then what do we get? After minerals we get rocks. So what are rocks? Rocks are nothing but called as mechanical aggregates of minerals. Understood? So we'll get minerals from elements and we'll get rock from minerals. So mechanical aggregate of different minerals, we get rocks, right? So magma, when it intrudes the earth's crust, it will solidify, it will cool down, it will solidify, resulting in formation of different minerals, and these minerals combine to form what? Combine to form rocks. What kind of rocks? Igneous rocks, right? So these minerals which contain metals are called as metallic minerals. So if a mineral does not have a metallic mineral, what will we call it? We'll get non-metallic mineral. Understood? So minerals which are having metals are called as metallic minerals, and these metallic minerals which are profitably mined are called as ores. So what are ores? Ores are nothing but metallic minerals which are being mined. Understood this part? Now when we are mining ore, we also get what? Impurities, right? So why do we mine ores? We mine ores to get metallic minerals, right? So along with metallic minerals, there will be presence of some unwanted substances or impurities, right? So what are these impurities called as? These impurities are called as gangs. Understood? So what are ores? Ores are nothing but metallic minerals plus gang. Understood? Fine. So the minerals which contain metals are called as metallic minerals, and the metallic minerals which are profitably mined are called as ores. Okay, this has been repeated. Fine, chalo. Alright, now let us talk about minerals on the earth's crust. Now on the earth's crust, it is made up of how many types of minerals? Around 2000 type of minerals. But out of these 2000, only 6 are abundant and contributes the maximum. In case of elements, out of all the elements, what were the major constituents? 8 elements were the major constituents, right? Out of these, what was the highest? It was oxygen, right? But in case of the minerals, elements was oxygen and 8 elements. In case of minerals, on the earth's crust, how many minerals do we find? We find around 2000 minerals. And out of these 2000 minerals, how many are abundant? 6 are abundant in total. And what are these 6 minerals? First is feldspar. Feldspar is a combination of silicon as well as oxygen. Then we have quartz, which is made up of silica. Then we have pyroxenes, which is made up of calcium element, magnesium, aluminium, iron, silicon. Then we have the amphiboles, which is made up of aluminium, silicon, iron, magnesium. Then we have mica, which is made up of potassium, aluminium, magnesium, iron, silicon. And then we have olivine, which is made up of magnesium, iron and silica. Understood? What are these 6 elements or the 6 minerals? Feldspar, quartz, pyroxenes, amphiboles, mica and olivine. Fine. Alright. So since we have talked about the elements on the earth's crust as well as the minerals, now let us move on to the next topic and understand the rocks in the earth's crust. Alright. Now rocks are considered to be what? These are considered to be mechanical aggregates or physical mixtures of different minerals. We have already defined, right? So all the minerals will aggregate, which will result in formation of rocks. So feldspar and quartz are the minerals which are most commonly found in the rocks. So in the rocks, which are the 2 most commonly found minerals? These are feldspar and quartz. The scientific study of rocks is called as petrology. What is it called? It is called as petrology. Okay, remember this term. Now how do we classify rocks? So rocks are classified into 3 different groups. The first one is called as the igneous rocks. The second one is called as your sedimentary rocks, and the third one is called as your metamorphic rocks. So in this class today, we shall be talking about the igneous rocks only, and in the next session we will talk about the sedimentary rocks and the metamorphic rocks. Fine. Chalo, let's proceed with the class and talk about the igneous rocks. So what are igneous rocks? Igneous rocks are those rocks which are formed out of solidification of magma and lava. Fine. And are known as igneous or primary rocks. So what is the other name of igneous rock? It is also called as a primary rock. Fine. Now how do we get, or what is the source of origin of igneous rock? The source of igneous rock is either magma or lava. Now what is the difference between magma and lava? This is very, very important to understand. Now this is the earth's crust, right? From below, what will we get? Magma will flow, mantle convection cell of Arthur Holmes, remember. So magma will flow upwards, right? And it will break open the earth's crust and magmatic eruptions will take place where? In the surface of the earth, right? So this this magma, which is intruding the earth's crust and reaching the surface of the earth, this magma will then be called as a lava. Understood the difference between magma and lava? It is called as magma when it is present below the earth's crust. Once magma intrudes the earth crust, magma will be called as a lava. That is the only difference. Alright, only the name changes, magma to lava. That's the only difference between magma and lava. Fine. Now what is the basic characteristics of igneous rocks? Now this is very, very important. First, it is non-fossiliferous, meaning what? In igneous rock we do not find presence of fossils. Alright, fossils are found in the sedimentary rocks, we'll talk about it, but in igneous rocks we do not find fossils, and hence it is called as a non-fossiliferous. Then it is crystalline in structure, and then it is non-stratified in nature. Non-stratified means what? The igneous rocks will not have any layers or will not have any stratification. Understood this? So this is not present where? This is not present in your igneous rocks. So in igneous rocks can be called as non-stratified, meaning it will not have any layers. Fine. Chalo, now let us talk about the classification of the igneous rocks. Now there are two different ways by which we can classify your igneous rock. Fine. Number one is called as your based on time and place, and there is another one which is called as your based on chemical composition or content of silica. Fine. So the first thing that we'll talk about is your classification of igneous rock based on time and place of cooling. Fine. So based on this, it is classified into two types. The first one is called as your intrusive igneous or plutonic rocks. Remember both the terms, plutonic rocks and intrusive rocks. Fine. So the first one is your intrusive igneous rock or plutonic rocks. So what are these intrusive rocks? These are formed when magma solidifies below the earth's surface, right? This is the crust, magma is flowing upwards, volcanic eruptions, right? So here it will be called as lava and here it will be called as magma. So this magma, even before reaching the earth's crust, if it solidifies and cools, if it cools and solidifies inside the earth's crust, even before reaching the crust, it will be called as a plutonic rock. Understood? When magma cools, we call it as formation of igneous rocks, right? So when this cooling of the magma takes place below the earth's crust, we get what type of rock? We get plutonic or intrusive igneous rocks, right? So the rate of cooling below the earth's surface, this point is very important, please look at it. The rate of cooling below the earth's surface is very slow, which gives rise to formation of large crystals in the rock. So the plutonic rocks which are forming below the earth's surface, what will happen? These will have large crystals. Understood this? Why so? Because the rate of cooling inside the earth's surface is very, very slow. Understood? So these will be coarse grains. Alright, coarse grain structure, meaning large crystals will be found in these rocks. That means what? That is, the mineral grains of the intrusive rocks will be very, very large. And what is the example of an intrusive igneous rock? It is granite. Kindly remember, granite is an example of plutonic rock, meaning granite is found where? Below the earth's crust. Fine. Okay, the next type that we have is called as a extrusive igneous rock or volcanic rock. First one was called as intrusive or plutonic. Next one is called as extrusive, meaning exterior or volcanic rocks. So what are these rocks? So in this case, what will happen? Magma will intrude the earth's crust and will get lava on the earth's surface, right? So when this lava cools down on the earth's surface, what kind of rocks will we get? We'll get volcanic rocks or extrusive igneous rocks. Understood the difference? Fine. So they are formed by cooling of the lava on the earth's surface. So as the lava cools very rapidly, because in this case what is happening, cooling is taking place in the earth's surface and not at the interiors, right? So in this case the rate of cooling, what will happen to it? The rate of cooling is very fast, or it is much more faster compared to that of your plutonic rocks, right? So as the rate of cooling is very fast, the mineral crystals forming this will be very fine. So meaning what? Unlike the plutonic rocks which were coarse grained, in this case we will get rocks which are fine grained or will have smaller crystals. Understood this? Fine. What are the examples? Basalt and then gabbro also. Basalt, ocean floor is made up of basalt, and mountains, when we talked about it in the plate tectonics theory, mountains are made up of granite. That's why if you look at the structure like this, the mountains are of this structure, right? So if you look below, the core of the mountain which is found here, this is made up of granite. Fine. So the core of the mountains is granitic in origin. Fine. Next point, the volcanic rocks contains greater proportion of basic oxides, meaning example iron, aluminium and magnesium, and thus are denser and darker in color. This means what? This means that the volcanic rocks, what will happen to this? Volcanic rocks will have greater proportion of basic oxides like iron, aluminium and magnesium. So because of this, what happened? Because of these, volcanic rocks or extrusive igneous rocks will be denser and darker. Then on the contrary, what will happen to your plutonic rocks? Plutonic rocks will be lighter in color as well as density will also be lesser. This is also another difference. Fine. So your volcanic rocks are denser and darker. Your plutonic rocks are lighter in color as well as density is also very less. The third type of rock that we get is called as a hyperbasal or intermediate rock. So till now we had the extrusive igneous rock, then we had the intrusive igneous rock. Now we have intermediate rock. Now what are these intermediate rocks? So these rocks occupy an intermediate position between the deep seated plutonic bodies and these surface lava flows. Meaning what? Meaning that, okay, I will show you a diagram. Now if this is the earth's crust, magma is cooling down here. If magma cools down here, what do we get? We get intrusive rocks, right? When the lava cools here, we get what? We get extrusive igneous rock. But when magma cools in a position which is just below the earth crust, alright, when the magma is cooling at a lower depth compared to that of your intrusive igneous rock, we get hyperbasal rocks. Understood this? Understood what are hyperbasal rocks? So where are these hyperbasal rocks found? Hyperbasal rocks are found in between, above the extrusive igneous rocks, and in below we will have the intrusive igneous rocks. Fine. So such type of igneous rocks will include silts, dikes, batholith, phacolith, laccolith. See, these are the structures. What is the structure of silt look like? It is like a concave shape, right? Then we have the lopolith here, then we have the phacoliths, then we have the batholith, which is a very large body. So beyond this, what kind of rocks will we have in the layers below the batholith? We will have the intrusive igneous rocks. Understood this? So these terminologies that you see here, silts, dikes, batholiths, phacoliths, laccoliths, so these can be considered as volcanic landforms or not, right? Because what is the source of volcanoes? It is magma. So this is a very interesting topic, silts, dikes, batholith, phacolith and laccolith, and this will be more extensively dealt with in your topic of volcanic landforms. Fine. So for the time being, just understand that silts, dikes, batholiths, phacoliths and laccoliths are example of hyperbasal or intermediate rocks. So what are these, or what their structure looks like, we'll talk in the volcanic landform or the volcanism chapter. Fine. Okay, so this was the first basis of classification. So what was the first basis of classification? It was on the basis of time and place of cooling, right? So now we'll talk about the classification of the igneous rock on the basis of chemical composition. On the basis of chemical composition, it is classified into acidic rocks and basic rocks. So what are acidic rocks? So these are the rocks which are characterized by high content of silica, that means quartz and feldspar up to 80%. So the rocks which will have higher content of silica, we will call it as what? We will call it as acidic rocks. Fine. So these are made up of 80% is quartz and feldspar, rest includes your aluminum, magnesium, lime. Fine. So what is this characteristics? Let us talk about the characteristics of acidic rocks. First thing, let's look at the point. These rocks have lesser content of heavier minerals like iron and magnesium. Fine. Hence they are less dense and are lighter in color than the basic rocks. So what is the characteristics of acidic rock? It is less dense because it does not contain minerals which are on the heavier side, and secondly it is also lighter in color. Now due to, third point is important, due to excess of silica, acidic magma cools faster and it does not flow and spread. Understood this point? Silica content is very high, meaning what? If silica content is very high, its cooling rate will also be very fast. As a result of this, what will happen? This rock or this magma which is coming out, it will not flow in both the direction. Understood this point? So its flow is very less, rather it is very resistant in nature because its cooling rate is very fast. Understood this point? So due to excessive silica, the cooling rate is very fast and it does not flow. It would have only flowed when it was in the liquid state or semi molten state, right? But its cooling rate is very fast, therefore it gets solidified also very fast. Therefore even before able to spread, it cools down. Understood this point? Fine. Next point, these rocks are hard, compact, massive and resistant to weathering. Understood this point? So these are the basic characteristics of your acidic rocks. Next we have your basic rocks. So basic rocks will be just opposite to that of your acidic rock. So basic rocks are what? These rocks are poor in silica content, only up to 40%. In that case it was up to how much percent? 80%, right? Fine. So magnesia content is also up to 40%. So silica 40%, magnesia content is also 40%, and rest will include your iron oxide, lime, aluminum, alkali and potassium. Now since here we have the presence of iron oxide, meaning what? Meaning that the basic rocks will be darker in color as well as it will be denser in nature. Understood? Acidic rock was not having iron oxides, therefore it was lighter in color and less denser, but basic rocks have iron oxides, therefore it is darker and also having higher density. Now due to low silica content, what will happen to its cooling rate? In this case your cooling rate will be very less. As a result of this, what will happen? If its cooling rate is very less, what will happen? It will flow and spread far away. So this flow and cooling gives rise to plateaus. Alright. So when, see, now look at this crust. Suppose the magma is flowing and breaking the earth's crust. Example, if it is breaking the earth's crust, suppose this is a basic magma. Suppose the magma is basic in nature, meaning it has less content of silica. So what will happen to this lava? This lava will flow in both the direction, right? So once this lava flows in both the direction, it will cool down, right? It will cool and solidify, therefore we will get a structure of this kind. So this becomes your plateaus. Similarly, if we talk about the acidic rocks, what are happening in acidic rocks? In acidic rocks, the cooling rate is very fast. So as the magma is intruding and becoming lava, as the cooling rate is very fast, it is not able to spread in both the direction because even before spreading it cools down, right? Therefore it will accumulate where? It will accumulate one over the other. So we will get what? We will get volcanic mountains. So in case of acidic rocks or in case of acidic magma, we get volcanic mountains, and in case of basic magma or lava, we get what? We get plateaus, right? Fine, we get plateaus. Alright, so this is about your basic rocks. Now before going into the question section, let us do a quick recap. Fine. So what did we learn today? The first thing that we learned today is about your elements. So what are elements? Elements are pure substances having atoms, and this cannot be broken down by chemical processes, right? So when these elements combine, it results in formation of minerals. All right. So what are minerals? Minerals are nothing but it's a combination of different elements. However, on Earth we can also find minerals which are having single element only. Now if you are talking about element, which is the highest element found on the Earth's crust, it is oxygen followed by silicon, right? And then we have aluminium and iron. But in case of the overall Earth, what do we have the highest? The highest is iron followed by oxygen, silicon, and then magnesium. Fine. Now minerals can be both organic and inorganic, right? So what is the basic source of all minerals? The basic source of all minerals is your magma. So when this magma will cool, what will happen? It will give us different minerals, and these minerals combine to form rocks. Understood? So from elements we get minerals, from minerals we get rocks. So what are rocks? Rocks are nothing but mechanical aggregates of minerals. Fine. All right. So metallic minerals which are mined are called as ores. So in ores we'll have metallic minerals as well as impurities or unwanted substances, and those unwanted substances are called as gangues. Fine. So metallic minerals plus gangues are called as ores. Understood? All right. Fine. Now what are the 6 very important minerals that we get on the Earth's crust? We get feldspar, quartz, pyroxenes, amphiboles, mica, and olivine. Fine. Then out of all the minerals, which are the most common? It is feldspar and quartz. The study of rock is called as petrology. So we have classified the rocks into 3 groups: igneous, sedimentary, and metamorphic. And igneous rocks can in turn be classified in 2 ways. The first way is called as what? The first, it is classified on the basis of time and place of cooling. Understood this point? We'll talk about it. But what is the basic characteristics of igneous rock? It is non-fossiliferous. That means it does not contain fossils. It has a crystalline structure, and then it is non-stratified in nature. That means it does not have layers. So classification on the basis of time and place is your first one is your intrusive rock or plutonic, because in this case what is happening? In this case magma is cooling below the Earth's crust, and in this area what is happening? The cooling rate is very slow, right? As a result of this we get structures which are coarse grained. Example is granite. And the contrary, if when the magma becomes lava, once it intrudes the Earth's crust, the cooling rate will become very fast, right? So as a result of this, what will we get? We'll get structure which are very fine grained in nature. Example is your basalt and gabbro. So in case of your basic rocks, what is happening? It is containing basic oxides like iron and aluminium. Therefore it is much more denser and darker in color. And on the other hand, what will happen to your intrusive rocks? These are lighter in color as well as it is less denser. Then we have intermediate rocks also, which is found between your intrusive and extrusive rocks. And what are the different types of igneous rocks? Silts, dikes, batholith, phacolith, and laccolith. We'll talk about this in volcanism chapter. Now based on chemical composition, it is divided into acidic and basic, right? Acidic means that these rocks or the magma will have higher content of silica. Now because of higher content of silica, its cooling rate is very fast. Therefore it cannot flow in both the direction. Therefore the cooling will take place one above the other. As a result of this, what do we get? We get volcanic mountains. But in case of basic rocks, what is happening? In case of basic rocks, the silica content is very low, and because of that, what is happening? Because of that, it is flowing in both the direction and then it is cooling down. Therefore we get a structure with a very less elevation, which is called as your plateaus. Fine. Now if we have to talk about acidic rocks are very resistant to weathering. It is hard, compact, and massive. Correspondingly, basic rocks are not that resistant to weathering. Fine. Now let's look into some questions. So what is the first question? Which of the following are properties of quartz? It consists of silica. It is insoluble in water. It is used in radio and radar. The correct answer is what? The correct answer is D, all of the above. That means it consists of silica. It is insoluble in water because it is resistant. And it is non-porous. Then it is used in radio and radar as well. Fine. Now what is the next question? Next question says, consider the following statements regarding minerals found in the Earth's crust. The basic source of all minerals is hot magma in the interiors of the Earth. Minerals are always found, second statement, minerals are always found in the Earth's crust in combination with 2 or more elements. The statement 1 is correct because what is the basic source of all minerals? We have studied it is hot magma, right? But the second statement is not correct. Why? Because minerals can be found as combination of elements, but in certain cases it can also be found as a single element as well. So what is the correct answer? Correct answer is A. That means only statement 1 is correct. All right. So I hope you understood the differences that exist between elements, minerals and rocks. And I hope that you also understood what are igneous rocks and their different types. So in the next class, we'll move on with the topic of rocks and talk about sedimentary rocks as well as your metamorphic rocks. So stay tuned to Scholar.